So welcome, guys and girls. So this is the final session of today, and I'm really pleased to have Namit Jain, SVP of Engineering at Qubole. Namit brings over 2 decades worth of experience in the data warehousing and big data world, more than 30 patents to his name, and he's got a background across Indian unicorn startups and also based in the US. And Namit's been with us for a couple of months now, so. Over to you, and welcome.
Thanks a lot, Matt. Thanks for the introduction. I've been here for about 10 weeks now, and before that I was at Nutanix, and before that at Facebook, handling most of the stuff on-prem. So basically today I will talk about our journey in building big data as a service, the various decisions that Qubole has taken at various points of time, what has worked for us, what possibly can we do better, etc., etc. Please feel free to interrupt if you have any questions. I'll be more than happy to answer them. So so this is like the various decision points that we have taken and the key guiding principles. So let's start with some of the metrics. As most of you have seen, like some of the growth charts, just wanted to focus on some of them. So we are growing. Like this is the chart of the monthly active users, quarter over quarter over last like 2 years or so. So as you can see, the number of active users have grown like nearly 8 times, from nearly 500 to like 4,000 plus. So a good chart to have. Similarly, this is the chart for the total number of active clusters, again grouped quarter over the last 2 years. Again, a pretty healthy trend here. So we have grown like nearly 7 times, from order of 1,000 plus clusters to around 7,000 clusters. So a good growth. And then this is the number of total commands run, again quarter over quarter. Again, we are doing pretty well here. As you can see, like we have grown from about 5 million to about 23 million in about 2 years. Again, roughly a 5x growth. So this has been a general trend here. And I just wanted to, since we are a data-driven company, and we use Qubole on Qubole to kind of get these insights. So some of the key insights I wanted to bring out. And I'll talk about more details, but I think Ashish mentioned about it in his note today about the multi-engine thing. This was one of the early decisions that we took as a company, that we'll be supporting multiple engines when we were pretty small. So this graph shows the number of customers which are using a particular engine. Like the blue bar represents Hive, and the green one represents the number of customers which are using all the 3 engines, Hive, Presto, and Spark. Right? As you can see, over the years, the number of customers who are using multiple engines have grown. Like the light green bar has grown like nearly 3 times, from like 30 to 90 odd customers which are using all 3 engines. Similarly, the number of customers which are using 2+ engines has been steadily growing. And this has been one of the decisions that we made early on, and this has really paid off. A similar data point here, but based on the number of users who are using multiple engines. So this is kind of different from the number of customers, because a customer can have multiple accounts and multiple users. And the initial observation was that it's possible that a single user is only using a single engine. However, as you can see, what we are seeing more and more is a single user is using multiple engines. So if you see to the left, like more than 90% of the users used to use a single engine. In somewhere in between 2017, Q1, the number was close to like 2/3, and now the number is like close to 50%. So clearly we are seeing trend where not only a customer but a user is also using multiple engines. I'll go into more details here about the cost savings and what we have done for the savings. But this is the chart about the savings that we have gotten due to using Spot aggressively. And I'll go into more details later on. But essentially, we are generating about $10 million savings quarter over quarter for our customers. So let's start with the deep dive of the journey, what decisions we took, what are some of the guiding principles. So although this company was started like a long time back, but took a lot of hard work from a lot of people to get it where it is. So I'll go over some of the key decisions that we took. So these are the key guiding principles of the company, right? Use open source extensively. no engine bias, etc., etc. So let's talk about some of them in detail, right? So we don't have, although we use open source extensively, we don't have an engine bias. So as and when open source engines became available, we were more than open to use them. We started with Hive, Hadoop, Pig in the early days, but started using Presto and Spark as and when they became popular. And we are also supporting Airflow. And this hopefully will continue to increase. As and when like new engines like TensorFlow, etc., become popular, we will be able to use them. So that is one of the key guiding principles. So we are not married to a particular engine. We are not married to a particular workload. We are building a platform instead of building a one-off solution. So by that, what I mean is we are, again, this is a pretty heavy slide. I won't go over details over here. But as you can see, we are building a platform which caters to multiple personas: the analysts, the data scientists, the data engineers, and the data admins. We are not building a one-off solution. So this inherently means that we are supporting multiple workloads. We have to cater at multiple UX, which is simplified for multiple clouds and multiple personas. And this is, again, one of the early decisions we took, and this is paying off. It's one thing to use an engine, open source engine, but it takes a lot to run it, right? So we have to invest a lot in innovation. Now, that innovation can come in multiple forms. Like we have innovated in services around the open source engines, be in terms of cost savings, performance, stability, and security. And also we have innovated across in the engines itself. So I'll give us a lot of examples where we have done a lot of innovations which are agnostic to the engine so that they can be used across and the benefits are not specific to a particular engine. So I'll go over some of the improvements there. Then another key guiding principle for the company has been that we have invested in a lot in partnerships. So it was very clear that we cannot do everything alone, right? So the partnerships can be with the cloud vendors, be it AWS, Azure, Oracle, GCP, data warehouses like Snowflake, you might have read, we have recently partnered with them. More and more you will see that we are partnering more with the BI vendors, and again, we'll be partnering more with the ETL vendors. So we'll partner as and when required. And the other thing that some of you may not know, we have taken some tough decisions along the way. Especially for those of you who have started using Qubole recently, we have taken some tough decisions. We used to support HBase previously, so at some point we decided to abandon it because the surface area was was getting too big for us and we were spreading too thin. We postponed Shark, which was like a sequel on Spark at the beginning when it was not ready, and picked it up later on. One of the other tough decisions we took was we abandoned Oozie. So for those of you know, this was a critical build versus buy decision. So Oozie was an open source scheduler which was used pretty heavily, but it had a lot of issues, a lot of concurrency bugs, and it was storing states in multiple places. So we decided to invest in our own scheduler, which is much simpler, and we have gone with that. So basically, these have been some of the key guiding principles for us, and we have taken some tough decisions along the way. So with that, I just wanted to go into an architecture deep dive. So this slide you might have seen from before. So basically, we support on multiple clouds. So we have built an abstraction layer which helps us add new clouds as and when they become available. And then similarly, we support multiple engines, and then we have multiple personas which work on top of multiple engines. And all this we do with due importance to security. So I wanted to spend some time on the high-level architecture diagram. So basically, on the left side, we have the control plane, so-called control plane, which runs in the Qubole account. So what happens is when a customer fires a query, which can be coming from various sources. It can be coming from a browser, it can be coming from API, ATL job, or they can be directly using like ADBC, ODBC, JDBC via the third-party apps. They hit our web node tier, and then we queue them using our worker nodes. So all this is running in Qubole's account, and these auto-scale independently. As and when the load increases, these things auto-scale. And then basically the actual engines run in the customer's tier. So, and these engines are where we are using a lot of open source stuff, and these auto-scale independently. So one of the key observations I wanted to make was that this was an early decision we took, and there was a lot of focus on security. So as you can see here, like we are never accessing the data. The customer's data is being accessed by the account in which the cluster is running in the customer's account where the data is being accessed. So Qubole is never accessing the data directly for a customer. So this was one of the key security principles that we took. And as you can see there have been a lot of enhancements in this over the years. So recently what we are working on is, this is a pretty fat worker process. So we are working on splitting it up into asynchronous processes so that we don't have to run this process for a long time. We asynchronously submit the job and wait for them as and when the results come in. So there have been innovations not only in the engines, but also in the control plane along the time. So now I wanted to focus more on the engines, and that's where a lot of innovations have happened and a lot of savings have happened. So basically, let's look at this slide. This is a pretty heavy slide, but let's go over it slowly. So essentially, when you come in, all you have to do as a customer is configure the cluster. So essentially, you specify what type of nodes do you want to use. You specify the spot instances, the price you are willing to pay, the percentage of spot nodes you want to use. Beyond that, everything happens for you under the covers. So let's go over this slowly. So the first thing that happens is we provision the cluster. We auto start the cluster. And then we continuously monitor the cluster. We see what kind of workloads are running on the cluster. Based on that, we can scale the cluster as and when required. As the load is added, we auto scale both up and down. Note that we not only do like a node upscaling, we also do a EBS upscaling. So in some cases, you just can add a disk and use the same nodes. In some cases, it's possible that you don't get the on-demand, the spot clusters as and when you wanted. So in the background, we do spot rebalancing. So for example, if you wanted like 50% spot, and you ended up not getting those spots, and you ended up running like 90% on-demand. So at that time, we will get an on-demand resource. But in the background, we will try to clean it up as much as possible. Not only that, like for every cluster, basically you specify a minimum number of nodes and a maximum number of nodes. And if the cluster is not running for a certain time, we auto-terminate the cluster. So these techniques basically result in cost savings for the customers, and I will go into more details about that. The other key thing I wanted to mention about is the zero downtime upgrade in the provision. So whenever a new release gets released, the customers don't need to know about that. So when the cluster gets stopped and when it gets restarted, it automatically picks up the new release. So everything happens transparently as far as the customers are concerned. So let's talk about this term Qubonomics, how Qubole reduces the EC2 cost. So you must have heard like Ashish's slide that we saved like $100 million for our customers. But let's just understand what all ways are we saving. Sorry for the font. This is like 11 and 12, and this got screwed up. But essentially, if you are running on an on-prem world, or like in one of the in one of the technologies which were not designed to be cloud aware, then essentially, if you are running like 20 node cluster over 37 days, this is what you will pay for, because you will have to essentially provision for the maximum. So this means that even though you may be using those 20 nodes for some time only, you will be paying for those 20 nodes on all 37 hours. So this is like if you were using an on-prem cluster or using some of our competitors which are not cloud aware. So the first thing that Qubole does to save costs is basically it terminates the cluster when there is no activity. So when you configure a cluster, there is a downtime. If there is no activity, the cluster automatically shuts down after some time. So essentially in this example, like let's say in our 11 to 16, there is no activity. So the cluster will automatically shut down. So these blue things are the savings. And this can be, again, this is workload aware. This depends on your workload, but this can lead to a lot of savings as far as the customers are concerned. So this is the first savings that the customers get due to no activity on the cluster. The next thing I want to talk about is autoscaling. This was one of the early features that was built by Qubole since this was built cloud up. So nodes are added on demand to cluster only when the workload requires more resource capacity. So in this example, which is a fabricated example, but may represent a real load, as you can see, the max capacity is required only for these 2 hours and these 3 hours, right? So only 5 hours the max capacity is required. So after R1, when you start with the minimum number of nodes, we will add nodes only as and when they need it. So 3 nodes are added on R2, 3 more nodes are added on R3, and then when the load goes down, those nodes are kind of downscaled. So this again leads to a lot of savings because you are doing a workload-aware autoscaling. Yeah.
Is it at the granularity of a Hive job? So if 5 Hive queries took 3 nodes and 10 Hive queries will take 6 nodes, is it that granularity?
No, it's at the task level granularity. So each one job can, depending on the workload that it has, if it requires like 100 nodes, it will spin all 100 nodes, assuming your max is 100. So it's not at the level of number of queries or number of, it's totally at the task level granularity. It's completely dynamic. So when the query finishes, it will automatically come down. So there is a cooldown period, but eventually it comes down. Yeah. So it's pretty optimized at that level. And the last thing that we have invested a lot is, and I showed a chart on spot savings, is on spot. So this light blue chart represents spot. So as I said before, when you configure a cluster, you specify the percentage of spot and the price at which you want to use. So we use spot aggressively, and it can save up to 70% of the instance cost, right? I mean, so again, it depends on workload to workload, and but we have seen our customers use like more than 50% of cases they are using spot nodes. So, and again, I wanted to go back to this chart where we are showing the spot node savings. So basically, assuming we are saving like 70% of the cost by using spot nodes, this is the savings that we get over the years, right? So this quarter we are saving like roughly $10 million by using spot nodes. So this is one of our key optimizations. So I talked about some of the cost optimizations, which are again, note that these are all engine agnostic. These are just, and cloud agnostic. They will work on all clouds. Let me talk about some of the performance enhancements that were done. I'll just break them down into 2. Like most of these performance enhancements were engine agnostic and cloud agnostic. And the last one, the SQL optimizations, are specific to a particular engine. So note that some of these optimizations were done in the open source and we picked them, or we re-implemented them, and some of them we have done completely outside our domain. So I'll not, in the interest of time, I'll not go into details of all of them, but we have invested a lot in cluster start time. At the beginning itself, we did a lot of file system optimizations to reduce the number of S3 calls. Again, we invested in direct writes. This is to write the data back to the S3. I'll talk into more details about the caching that we have done recently that is being rolled out with Rubix. I'll talk into detail about the fast copy. So these things are proprietary things that were done. They are not specific to an engine. I'll talk about them. And then the SQL optimizations like join, reorder, dynamic filtering, they have been done mostly in the open source, and we have picked them up. So let's talk about Rubix caching. So the idea here is to reduce the number of S3 calls, and this is completely integrated with Presto. So while you are reading the data, so essentially you go and read the data from S3, right? Assuming the data is on AWS on S3. So what we do is we create a cache based on like file name, file offset, and then that cache is stored on the same nodes on which like Rubix is running. So, and this is like a LRU cache, and then basically if the data is present in the cache, you don't need to go to S3, and you can just get the data from the cache. And note that this cache is never invalidated. Like if by whatever chance that S3 or gets changed or some through some Hive query or through Spark or directly, we keep a M time, the modification time of the file, so that we don't end up serving stale data. So this can lead to a lot of savings for the customer. Again, note that since we are lot of these performance enhancements indirectly also result in cost savings for the customer, because we are reducing the compute time. and less compute time means less cost for the customer. So this is the chart for we ran the TPCDS queries, and as you can see, this is the percentage gain that we achieved over various queries with rubrics and without rubrics. So I mean, yeah, the result varies on the query, but on an average we saw roughly double the performance improvement. And as I had mentioned before, this has been rolled out with Presto, and the usage, the adoption with Presto is going up, roughly 25% of the customers are using Presto with rubrics. So this is seeing pretty good adoption. The other obvious thing I wanted to mention about is Speedup versus sorted and unsorted data. So it's pretty obvious, if your data is sorted, then you will get better performance if you are querying on those columns on which the data is sorted, right? But it's a pain to sort the data yourself. I mean, it requires changing your ETL pipelines. It's not only a one-time activity of changing the ETL pipeline. I mean, it's very difficult to maintain that in the future. What if that data changes? How do you make sure that this sorted table is up to date? So what we have done is that we provide some recommendations based on the usage, that you should create sort columns, or we call them fast copy, on some of the columns. So basically, based on your usage, we say that for these tables, you should create fast copies of this data on these columns. And this is supported in all engines, this is supported in Spark SQL, Hive, and Presto. So what happens because of that is that in most of the cases, you are writing the data once and reading it multiple times. And this is completely agnostic to you. You don't have to make any changes in your ETL pipeline. So, and the query layer automatically rewrites the query if you are using the base table to reuse the new fast copy table. So that's one of the things that we are working on, and this should get rolled out in the next few releases. The other beauty of this approach is that this is integrated with all the engines. So in the worst case, let's say you are using Hive, but the base table got changed because of Presto. Then we have the Metastore listener, which will tell Hive to recreate the index or the fast copy. So you are guaranteed that if the fast copy you can think of as the index in some sense. If the index is invalid, then the query will just bypass the index, and if the index is valid, then it will automatically get used. And the index is created in the background, so what happens is the job gets submitted to the control plane from where it gets triggered and done. So this is some of the optimizations that we are working on, which is kind of engine agnostic but applies to all the engines. So yeah. So these are some of the other things that we are working on. One very important thing that I wanted to talk about was enterprise stability. So I mean, till now I mostly talked about innovation, cost, performance improvements, etc., etc. But as our number of customers are increasing, we cannot afford to go wrong, right? I mean, I remember somebody today, David, I think from Facebook, he was talking about that they run the queries to make sure that the results are the same, and they do some performance monitoring to make sure that they are not introducing any regressions in Presto in the daily releases. But for us, it's a pretty difficult problem because the customers are outside. We typically don't have their access to their workloads. So despite the fact that we have invested a lot in testing, monitoring, it's possible sometimes that we may run into issues that we will find in the field. So we are investing in staged rollout and fallback. So let me spend some time on this. So this is a new feature that will come in this release. So what used to happen till now was that let's assume the R52 stands for release 52, which is the latest release of the control plane. And let's say the previous release was R51, and the cluster release corresponding to R51 was 120.x. So previously what used to happen was that both the control plane and the data plane used to get released simultaneously at the same time. When a new release gets released, both of them used to get released at the same time. Now what we are working towards is that basically the new control plane will get released, the latest release, and let's say the R51 the old cluster plane release is 120, whereas R52, the new release is 121. So the control plane will get released. However, it will be compatible with both the old data plane as well as the new data plane. And it gives the customers a choice to upgrade it slowly. So this way, basically what we are asking all the customers to do is to create test accounts, canary accounts, where we can deploy the new releases first. And then do your testing, and if things go well, I mean, you better find bugs in the test accounts and fix all of them, and then upgrade to the production only after doing enough testing in canary. So this is a new thing that we will be launching, and we'll also be supporting fallback. In case something goes wrong, despite everything, whatever we did, you can always fall back to the previous cluster release that was there. So this will come in this release. And this is, note that this is not similar to the blue-green deployment that many web companies do. It's a either or right now, but we may go towards that. And the other thing that we may do eventually is that we will stagger it, and even the control plane may have a staggered release. That is the future. But right now, this is coming up in the next release. And basically, this will be provided at the global level, the account level, the segment level, and the customer level. So you can just basically do kind of an early check-in. Right now, this will be only controlled by the admin, but eventually this we want to roll out to the customers themselves. So the idea here is that as a customer, you can decide which release to use, which feature to use, and you can do like your own IT. So this was like most of the things I talked about, what has been going on, what went well. So wanted to spend some time on looking ahead and what do we want to do. So basically, again, this is the data that we are collecting from our own usage. So this data shows that what is our machine types used per account, and the minimum number of nodes and the maximum number of nodes. So as you can see, the minimum number of nodes per account has not changed much. It is like roughly 3 nodes over the years, right, over like last 2 years. And the maximum number of nodes, although it has shown some variation, but max is very difficult to derive anything out of it because there may be an anomaly. So basically what we are seeing clearly here is that we are not able to actually increase the support of heterogeneous clusters, although that's what we want to do. So that's where we would like to invest more in. And right now, that is one area where we would like to invest more. So, I mean, so in configurations today, we let the user specify various configurations, but maybe we can do better there. And we don't even ask for configurations and automatically choose what the customers want, or do a better job there. But this is one area where we can definitely improve, and we can improve here. The other thing is, like, this is the average number of basically nodes in a cluster. So again, as you can see, the average number of nodes in a cluster over the time has been reasonably constant. In fact, it has gone down slightly. And the max nodes, again, has been pretty much constant. I mean, it varies between 45 and 49. It's very difficult to derive any like interesting stats out of this. So basically, clearly what this shows is that our customers are not using bigger clusters. They are using like similar size clusters, what they were using even before. And we need to do some work here. So this is one area of improvement that we need to do. And I think there were some deep dive talks for that. But one of the plans is that basically we need to invest in like user quotas so that you can kind of, this will be a first step towards like serverless, where you don't need to worry about the cluster size, and the quotas will automatically take care of it. And in one of the CAB sessions, what it came out was that people are little scared to use big clusters because of autoscaling. What if you have like 1,000 node cluster and one big job comes up, and then suddenly you will increase to like all 1,000 nodes and your cost will go up. So, and that's a very legitimate concern. So what we want to do is basically invest in other fields like user level quotas, etc., so that we want you to use bigger clusters, but with the like safeguards that we can provide. So this is one more area that we want to invest in. This chart shows the number of commands that are run that finish in less than 5 minutes. The blue one is the commands that finish in less than 5 minutes. The light blue ones are the ones that finish like within 5 minutes to 1 hour, and the brown one is like which takes more than 1 hour. So as you can see, there is a huge variation here also. I mean, while the like a good percentage of commands finish in like less than 5 minutes, the number of commands that take more than 5 minutes has been steadily increasing, and similarly the number of commands that take more than 1 hour also is steadily increasing. So a similar chart which shows the amount of data scanned per query is also very similar, and it has a lot of variation. So basically this goes to like one size does not fit all. So we have to support multiple workloads, and because of that we have to support multiple engines and do optimizations for multiple engines. So this is the common practices that we are seeing in our field. The last thing I wanted to talk about was like it has been mentioned by in pretty much all the sessions, like eventually the goal is to do serverless. The concept of whole cluster should go away from the customers, and yeah, so I don't have a slide for that, but this is like the eventual future that we will be gunning towards, and the first closed version of that is being released pretty soon. So I wanted to end by like going back to our key guiding principles that we had from the beginning. Not much has changed, and we continue to invest in them. We are continuing to use open source extensively. We will be having no engine bias. As new engines come up, we will use them. We are building a platform, so we are supporting all the personas. We'll continue our innovation. There'll be more and more effort on the partnerships. I think that is one area where we will definitely improve, and we will continue to take tough decisions. That's all I had. I think I wanted to keep 10 minutes for any questions that we have.